about. Thank you. And so it's good to have reporting tools, and reporting tools are like the mechanism where you're going to deliver something, but it's also good to make sure you have something that's very high quality that you're going to deliver. And when I think about this kind of thing, there are two parts to it. One is what are the basics, which are what's the best way graphically to present information. So that's the basics, and that's something that probably everybody in the room does all the time. Create this report to deliver this. Oftentimes the business people or whoever's the consumer of the report will say, you know, I want a bar graph, or I want rows of data, or I want a chart. You know, so many times that's set by the people who we provide the report to. Oftentimes we get some input into here's what they're trying to do, and then help them to execute that in a nice, clean fashion. And then the second part of that is, so there's reporting, and then something that's very popular these days is data science. And I think the whole BI world is kind of getting pulled up the chain a little bit, because we're being looked to more and more to provide insights, not just here's my green bar report, you know, here's what sales were last month, you know, by region or something like that. And so it's exciting to be able to play that role, to do even more. And the way that we do that, that demands skills about how do you demonstrate cause and effect. And so that's kind of the second part of the things that I'll talk about. And so, for the basics, so there's lots of work going on right now in this area. And one of the best people at presentation graphics is a guy named Stephen Few. So we'll go through his stuff, and then for the more complex stuff, when we start talking about trying to show cause and effect, there's a guy who pretty much started that area, and his name is Edward Tufte. I think he is a retired professor from Yale. He was actually born in St. Louis, and then after him, he did a lot of his major work about 10 years ago, and then many other people have followed him. So we'll try to talk a little bit about that stuff. Okay, so Stephen Few's guidelines is pretty much keep it simple, two-dimensional objects. And the simple part is really important, because there is a lot of knowledge that people have gained that when you build things, what you want to do is you want to know the basic components and know them very well, and then build things out of those basic components. And so you can deliver great things, and they may have some complexity to them, but that complexity is a result of using basic parts. And that is a theory that goes for software engineering as well as for graphics. And there's a TED Talk, there's a guy named Alan Kay. How many people know who Alan Kay is? Anybody? Nobody. Okay. So Alan Kay, you may not know his name, but he's the guy who actually invented the graphical user interface. He invented object-oriented computing, you know, and a couple other things along the way. And he has a TED Talk, and he talks about architecture. And, you know, he gives the example of like a brick. So a brick is a pretty basic building block, and you can take a whole bunch of bricks and just put them into a pile, and that's okay, but it doesn't look very elegant, and it doesn't give you too much. You can take those same bricks and you can build them into a cathedral. So by taking a basic building block and then another basic idea like an arch, and then just reusing those two things over and over and over again, you can come up with something really elegant. And actually, people do this with data visualization too. So, what are the basics? Simple two-dimensional objects, lines that show patterns across a range, and then they kind of build up from there. And sometimes people go overboard and they don't track back to those basic components, and they get in trouble, and they create just a huge pile. And we'll show one of those. And sometimes they do them, they respect the pieces and they build carefully, and they come up with really elegant things. And just to kind of take that idea another couple of steps, so there's a guy right now named Hadley Wickham. And Hadley Wickham is important because he is the chief data scientist at a company called RStudio. How many people have heard of RStudio? Okay, a few more hands. So RStudio is a really cool graphical tool that allows you to do things in a language called R. R is kind of like the language of statistical processing. And Hadley Wickham read a paper called The Grammar of Graphics. And then that's a pretty odd phrase, the grammar of graphics. But really it's just the same idea, that graphics have these basic important building blocks. You understand them, you respect them, and then you build up using those components. And that really, he made his whole career off that. He was a statistics professor. He created a really cool data visualization tool called ggplot, and now he's the chief scientist at RStudio. So then a couple other things. The idea that if you do have something that's complex, one way to get around that, instead of just throwing more things on the pile, is to have multiple visualizations. Don't try to do too much in any one thing. Have multiple so that the person can look at it, can intuitively grasp it, and then put it together. And then finally about filtering data. That's another way to keep from having too much at one time. You can't, it's hard. We'll show some slightly complex graphics, but there's a limit to what you can present visually and have somebody be able to take it in, have somebody to instinctively know the story you're trying to tell. So this is an example of doing it wrong. So this is from Stephen Few paper or booklet, and somebody in healthcare, somebody who is famous in healthcare, created this graphic, and they were trying to show healthcare costs for depression for a certain age group, and they tried to use all these different colors in curves and complex shapes. And when I look at that thing, I mean, it's colorful, but it really doesn't mean anything to me. And so he did not follow the rules. So the first thing that you can do is, just very intuitively, if you have a bar graph and you have just a couple of attributes you're looking at, percentage of patients, and then across different diseases, I mean, you can look at that bar graph and right away, you know what that is trying to tell you. And then rather than have circles layered on circles, then split those things out. So you have a couple of attributes here, you have percentage, a couple of attributes here, and a couple of attributes there. And then the person can look at that and just visually, intuitively know what's going on. So then this graphic, this is where he took every bit of information that was in that complex circle, and then he broke it out. I think that this page is a little busy. It's a little hard to, it's a little too much information, but there's his bar graphs across the top, and then he's trying to show patterns over a range, and so he uses simple lines, and on multicolored lines. He has on this is a little tool he developed. People can filter, they can select the different diseases they want to see. There's a slider for age range. And so he's trying to give the person, a very intuitive presentation where they can control things and instead of taking absolutely all that information and putting it into a single graphic. So this is just again, just to kind of review his basic concept that numbers hide patterns, and that's why we have graphics to do things simply, to use lines, to use multiple visualizations, and to filter. So does anyone have any questions about that? Okay. So that's kind of the building blocks, and then now we'll move on to Edward Tufte's stuff, and his idea is that you're always trying to show cause and effect. And I think that's if we get that chance to help out our customers and show them cause and effect, instead of just, they say, well, I would like this data, and then we format it in a clean bar graph or a clean chart. I mean, that's good work, but it's even more fun to get to help them understand cause and effect. And so, for example, where I work at Scott Trade Securities, and there was a business analyst a long time ago, maybe 25 years ago, and he was working with the owner, and Scott Trade did discount trades, and the owner said, there's all these new technologies out, and I think that we should do trading over IVR. That we'll have to put less into it. We'll make a lot more money. That's a really, really good thing. And this business analyst said to him, hey, you know what? I think you should do that on the internet. And then from there, our company had explosive growth. That gentleman still works at Scott Trade, and every couple of years he just talks to the owner and he decides what job he's going to have now. So wouldn't that be a great place to be? So it's good to be a reporting analyst. It's good to be a business intelligence person. If you're ready when the time comes and you can help your customers understand cause and effect, you might be the guy who gets to talk to the owner every couple of years and say, this is what I'd like to do now. So, and I think that's out there, and I think that's the whole data science movement, people having more sophisticated statistical and computing tools to help people instead of just going by their instinct to have data to support their decisions. So some of Edward Tufte's key points is to document the source and characteristics of the data. So you have to know the data. You have to actually look at the base data before it's aggregated, before it's averaged, because every time you do one of those manipulations, you could be obscuring whatever cause and effect there is. And then the whole thing is causality, but causality is very difficult, and so you have to quantify it, and you have to test it. You have to say what was my control group, what was my independent variables and dependent variables. There's a lot of scientific method behind that, knowing that I have so many independent variables and one dependent variable. This is my test case, this is my control case, so that you can be credible. And when you're saying something, the data really backs it up. And then finally, the idea that, so number one, causality is difficult, and number two, causality generally is multidimensional. Generally, there are many, many reasons why something happens. It's not just when the weather goes up, you know, when the temperature goes up, we sell more ice. You know, some things are that easy, but most things require many, many factors to produce some result. So that's where more complicated graphics, and we'll show a heat map. That's a pretty good mix of being complicated, showing multiple dimensions, but not being overly complicated. So Tufte has two examples that he likes to use about how to cases where people showed cause and effect, and this case is where somebody demonstrated cause and effect and it turned out well. And then the next one is a famous example of where people tried to do reporting and data visualization and things turned drastically, tragically wrong. So this case, it's amazing to me because there was a doctor in the 1850s in London, and there was a cholera epidemic, and people were dying by the hundreds, you know, and nobody could figure out how to solve this public health crisis. So what he did was he made a map, and he had a hunch. People didn't really even understand about bacteria in those days, but he had a hunch that that cholera was being transmitted through the water supply. And then he wanted to show that. He had to demonstrate that to the government so that the water supply could be stopped. And so what he did was he had a map, and in this particular area where a lot of people died, this is where the water pump was. And each of these black rectangles are actually coffins. And so each one represents somebody's death. And so when we laid it out graphically, what he showed was that there were many more deaths, that the closer you got to the pump, the more deaths you had, the farther you got away, the fewer there were. And he was kind of lucky because there were actually two outliers in the data set. So this one here, this yellow square, is actually a brewery. And in the 1850s, when the people worked at the brewery, they didn't drink water. They just drank beer all day long. And so nobody got sick there, you know. And then this other one was a workhouse, kind of an institution. And in addition to a little bit of pump water, they also had their own well. And so in that outlier, there are also very few deaths. And so what he does is that he has his cause and effect that the water, or being close to the water, causes death, and then he has a control. Well, these are control or also outliers. These people were close to the water, but there were no deaths. Well, why were there no deaths? Because they did not use that water supply. And I think what's really brilliant about this is he uses the distance to the water supply as a proxy. You know, he couldn't find out, he couldn't test each of those people and find out exactly what water they had drunk, except for, you know, what he knew about the brewery and the workhouse. And so he uses distance to the pump as a proxy for how much water they consumed. And so then with this visualization, he was able to convince the government that it was the water supply. They turned off the water supply, and the deaths from cholera just stopped. It just went downhill like a big curve, and then it was over. So that's an amazing thing that data visualization was used in the 1850s and saved a lot of lives. Some other things about it, too, is sort of like the cause and effect. He could have drawn a lot of graphs that just showed, like, deaths over time, that kind of thing. But time is not a very good explanatory variable, you know. You need something besides time. You need what are, if you're lucky, to zero in on the key factors. So the key factors here were a number of deaths and the water supply, he couldn't really test the water supply, so he used a proxy, which was distance to the water supply. So, and then the other example that he cites is the Challenger explosion. So they're getting ready to launch the Challenger, and the weather was cold. So NASA calls up the company that made the rockets for the Challenger and says, it's 28 degrees instead of 60 degrees. Do we still launch the Challenger? And what the rocket company did was, and this is just fake data, but they just sent over spreadsheets, and then they tried to talk their way through. And some of the engineers at the rocket company knew that as the temperature went down, the O-rings on the engine degraded. But they could not present that in a way. They had O-ring damage, and they had other damage, and it was all mixed together, and they could not cleanly demonstrate to NASA that the temperature was going to cause a problem. So since they couldn't demonstrate it, NASA launches the Challenger, then Challenger blows up. So what they should have done is they should have done this. So this is the number of O-ring failures starting at 0 on the bottom. So as the temperature goes up, the number of failures is 0. As the temperature goes down, the number of failures goes through the roof. And instead of sending over lots of spreadsheets, if they had sent over one simple graphic, two-dimensional with a line, focusing in on the key variables, the temperature and the damage to the O-rings, then they would not have launched that. So, so this is a heat map, and it's a pretty good way to show multi-dimensional data because you're using color for the one attribute. In this case, it's number of sales, and the red squares are low sales, and the green are the high, and then the size of the square it communicates another variable. So it's kind of a compromise between that circle graphic we saw at first and a graphic that is relatively intuitive, but also is multidimensional. So that is about all I have. If you want to do a deeper dive, here's like a handful of names. So I talked about Hadley-Wickham and the grammar of graphics. And there's a guy named Hans Rosling who has a bunch of TED Talks. He's a kind of a medical statistician, and he does really great things. You know, he starts with simple graphics, and sometimes he animates them, but he keeps it simple, and he's a great communicator. And then another key name to know is John Tukey, and the concept of what's called exploratory data analysis. So if you wanted to be a data scientist, one way that people do those kind of things is there is a course for free from Johns Hopkins on data science. And if I go out to all those massively online class experiences from Stanford and Coursera and those kind of places, that's how some people get into data science, is they take those courses, and almost all those courses have an element called exploratory data analysis. And what he did, he was a scientist back in the 70s, 80s, and 90s, and so you can plot the data and to explore relationships, and he's kind of the father of that whole thing. So that's another, it's a good term to know. People don't so much know John Tukey these days, but they sure know what exploratory data analysis is. So sometimes you graph things. His big thing was, okay, you got a bunch of data, well, let's start graphing it. Let's take very simple data, don't aggregate it, don't take the average, let's start graphing it, and let's see, he believed that people had the intuitive power to see patterns. So take your data, start graphing it, and see what you got. And rather than the reporting and the visualization just being at the end, oh, we've figured everything out, here, go make me a bar graph, that it's more of a process that you chart out the data, you get an insight, and then you see where that goes. So that's all I have. Are there any questions? Okay, so now we're going to transition to the how you deliver that content, and we're going to have Steve Howard from Microsoft talk about some of the new Microsoft stuff.
Hopefully this microphone's on over here. If anybody's online and they can't hear me,